Hello students, this is Shachi Tannan. Welcome to my channel Crack Chemistry. Today I am going to teach a class 11 topic. The name of the topic is Organic Chemistry, Some Basic Principles and Techniques Part 2. For Part 1 of this chapter, please check the I button. Students, before starting, I want to remind you to subscribe my channel for getting information about further important uploads. And don't forget to like and share this video with your friends. So now come with me and let's crack chemistry. So now see what we are going to study today. As I told you, the name of the topic is Organic Chemistry, Some Basic Principles and Techniques Part 2. In this topic, the topic which we are going to cover are structural representation of organic compounds. Then, in this topic, we will study complete, condensed and bond line formulas. Then, we will study bond line representation of some cyclic compounds. And in the end, we will discuss some of the NCERT problems. Students, now see, what do you mean by structural representation of organic compounds? Students, an organic compound can be represented in several ways. The Lewis structure, which is also called as Lewis dot structure, or dash structure, or condensed structure, and the bond line structural formulas are some of the common ways of representation of a structure of organic compounds. So, Lewis structure you have studied in the chapter chemical bonding, and you have seen that in Lewis structure, the number of shared pair of electrons are represented by means of a bond. And you have studied that while representing the Lewis structure of any compound, the shared pair of electron is represented by means of two dots. So, this Lewis structure can further be simplified by representing two electrons of the covalent bond by means of a dash. So, a single dash represents a single bond, a double dash represents a double bond, and a triple dash represents a triple bond. And lone pair of electrons on heteroatoms. Heteroatoms are atoms other than carbon and hydrogen. So lone pair of electrons on heteroatoms like oxygen, nitrogen, sulfur, halogens, etc. may or may not be shown. So now we will see how we can represent ethane, ethene, ethine and methanol by means of following structural formulas. So, such structural representations are called as complete structural formulas. So, first I am going to represent ethane here. So, ethane has the formula C2H6. In the complete structural formula, all the bonds involved are shown. So, between carbon and carbon, a single bond is there. And each carbon atom is attached to 3 hydrogen atoms by means of single bond. So you can see that this is the complete structural formula for ethane. In the similar way, we can write the complete structural formula for ethene. Molecular formula of ethene is C2H4. So between carbon and carbon, a double bond is present, and each double bonded carbon atom is attached to 2 hydrogen atoms. So this is the complete structural formula for ethene. Now we will see how we can represent ethyne by means of complete structural formula. So molecular formula of ethyne is C2H2. Between carbon and carbon, we have a triple bond, and each triple bonded carbon atom is attached to 1 hydrogen atom by means of single bond. Now, in the last, we will see how we can represent methanol. So, children, methanol has the molecular formula CH3OH. So I hope till now you will be able to write the complete structural formula. In case of methanol, the carbon atom is attached to 3 hydrogen atoms, which we are showing by means of a single dash, and then it is attached to oxygen, and oxygen in turn is attached to the hydrogen. And as I discussed with you in the beginning, the lone pair of electrons on the heteroatoms may or may not be shown. So this methanol can be represented in two ways. Here we are showing the two lone pair of electrons on oxygen atom, or one more way is there where these lone pair of electrons are not shown. So it can be represented in both ways. So CH3OH. So I hope it is clear to you now. Now one more point I would like to mention here, the structural formulas, the complete structural formulas which we have discussed just now, they can be further simplified, they can be further abbreviated by omitting some or all of the dashes representing the covalent bonds. And the number of identical groups which are attached to an atom are represented by means of a subscript. And the resulting structure is called as condensed structural formula. So now I am going to show how we can write ethane, ethene, ethyne and methanol by means of condensed structural formula. So now I am going to write the condensed structural formula for ethane. Molecular formula for ethane is C2H6, and I already told you that while writing the condensed structural formula, some or all the dashes may be omitted. So in case of ethane, between carbon and carbon a single bond is there, and each carbon atom is attached to 3 hydrogen atoms. So these hydrogen atoms are represented by means of the subscript, which represent the number of hydrogen atoms. Then again we have a carbon CH3. So it can be represented in two ways, as I told you that some or all the dashes may be omitted. So we can write it like this, CH3 or CH3 a dash between carbon and carbon, which represents a single bond. So this is the way of representation of ethane molecule. Now we will see how we can represent ethene. So ethene has the molecular formula C2H4. And we have already discussed that between carbon and carbon atom, in case of ethene, a double bond is present. So we are writing here C double bond C, and each carbon atom is attached to 2 hydrogen atoms. So CH2 and CH2. So this is the structure of ethene. So now we will see how we can represent ethane by means of condensed structural formula. So as I told you that the molecular formula of ethane is C2H6. So while writing the condensed structural formula, some or all the dashes are omitted. So each carbon atom is attached to 3 hydrogen atoms. So CH3, where 3 represents the number of hydrogen atoms and 3 is written as a subscript, CH3 single bond CH3, or one more way is there, we can write it simply as CH3. Here we have omitted all the dashes. So this was the structural representation of ethane by means of condensed structural formula. Now let's see how we can write ethene. So ethene is having the molecular formula C2H4. Between carbon and carbon, a double bond is present, and each double bonded carbon atom is attached to 2 hydrogen atoms. So we will write as CH2 double bond CH2. So this is the way to represent ethene by means of condensed structural formula. Now, next is the ethyne. So molecular formula of ethyne is C2H2. And we already know that between carbon and carbon a triple bond is there, and each triple bonded carbon atom is attached to 1 hydrogen atom. So this is the representation of ethyne molecule by means of condensed structural formula, and in the end we will write methanol. The formula of methanol is CH3OH. CH3. The carbon is attached to 3 hydrogen atoms. Then oxygen, CH3OH. So this is the way of representation of methanol by means of condensed structural formula. Similarly, one compound is shown here. You can see that if you count the number of carbon atoms, total 8 carbon atoms are here. So this compound is octane. So similarly, this octane can be further condensed too. Terminal CH3 will be written as it is. But in between we have 6 CH2 groups. So CH2 whole 6 again CH3. So this is the condensed structural formula for octane. Now, for further simplification, organic chemists use another way of representing structures in which only lines are used. We don't use atoms. So for further simplification, we use a structure in which only lines are used. So this structure is called as bond line representation of organic compounds, and in this bond line representation of organic compounds, carbon and hydrogen are not shown. And the lines representing carbon-carbon bonds are drawn in a zigzag fashion. So instead of writing carbon and hydrogen, we represent them by means of a line, and the lines which represent carbon-carbon bonds are drawn in a zigzag manner. So the only atoms which we write, which we specify are oxygen, chlorine, nitrogen, etc. means we specify the atoms. Then the terminals denote methyl group. Terminals means the end carbon atoms on both sides. The last carbon atom on both sides, they represents the methyl group. And if methyl group is not there, some other functional group is there, we represent them. And if no functional group is written, so terminals will always represent the methyl group. And one more point, the line junctions means the zigzag line. I told you that the bond between carbon and carbon are represented by zigzag line. Suppose this is one line and this is one line. So as I told you that this and will always, one more line I am writing here. So as I told you that these terminals will always represent a CH3 group until it is not mentioned. If some functional group is there, then it will be mentioned there. Then one more point I told here, that the lines junction, like this is a junction and this is a junction. So the line junctions represents the carbon atom which are bonded to appropriate number of hydrogen atoms which are required to satisfy the tetravalency. So I hope this point is clear to you. So some of the examples are represented as follows. So 3-methyl-octane can be represented in various forms as, so first of all, 3-methyl-octane means we have a chain of 8 carbon atoms. I am writing the 8 carbon atoms, CH3, CH2, and the third carbon atom as it has a methyl group, so there will be CH only, CH3. Then we have 5 more carbon atoms. So CH2, 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 CH3. So if you count, you can see that we have total 8. 1, 2, 3, 4, 5, 6, 7, 8. So this is the 3-methyl-octane. This is the structure of 3-methyl-octane. This is the complete structure. Then we are going to write this 3-methyl-octane by means of bond line notation. So as I told you that in bond line notation we don't represent the carbon and hydrogen atom. So I am writing here So 3-methyl octane. So first I'll write the first carbon atom, which is CH3, then CH2, then CH. This is the third carbon atom which is having a methyl group. So I am writing a methyl group here. Then again we have, you can see we have 8 carbon atoms total. So CH2, CH2, CH3. So if you count, you can see that we have a chain of 8 carbon atoms and a methyl group at third position. So now how to write this 3-methyl octane by means of bond line notation? Children, what we will do, we can convert the same line into bond line notation written like this. I would like to write this 3-methyl octane by bond line notation in the next slide. So you see that. First I am writing the 8 carbon simple octane I am writing here. You can see, if you want to count, you can count 1, 2, 3, 4, 5, 6, 7, 8. And the third carbon atom is having a methyl group. So children, this is the representation of 3-methyl octane by means of bond line notation. And one point I would like to mention here. This is 3-methyl octane, which is represented by bond line notation. Children, see, as I discussed with you, terminals. So, terminals means this is the one terminal, and this is also a terminal, and this is also a terminal. They represent CH3 group. So, terminals always represent CH3 group. Now, the junction between carbon and hydrogen, like this is the junction. I'll use a different color pen. So this junction is represented by carbon, and which is attached to sufficient number of hydrogen atoms to satisfy the tetravalency. So children, I hope this point is clear to you. Now I will take one more example. Various ways of representing 2-bromobutane are. So first I'll represent the 2-bromobutane by means of complete structure. So 2-bromobutane, 4 carbon atoms are here. So first I'll write CH3. But the second carbon atom is having a bromine. So instead of writing CH2, I'll write here CH. So you can see that the tetravalency of carbon must be satisfied. Then we have CH2, CH3. So students, this is the complete structure of 2-bromobutane. Now I am going to write this complete structure. This structure is complete structure. So I am writing here, this is the complete structure. Now I have to write this 2-bromobutane by means of bond line notation. So 2-bromobutane, first of all I'll write CH3. Then I will write CH. So this is the second carbon atom which is having a bromine atom. So this is the second carbon atom which is having a bromine atom. The 2-bromobutane, now I'll write one CH2 group and CH3. So this is 2-bromobutane. Now the same structure I would like to represent by means of bond line notation. You can see here that we have to represent 3-bromobutane. Total we have 4 carbon atoms, but the second carbon atom is having a bromine atom, so which you have to represent. Heteroatom you have to represent, and the carbon and hydrogen atoms are not represented. Again I'll write the same structure of 2-bromobutane on the next slide. So I'm writing here, this is 2-bromobutane. So how we will write 2-bromobutane? You see that first I have written butane only. You can count 1, 2, 3, 4. The second carbon atom is having a bromine atom, so you have to represent bromine. So you can see here, I'll use a different color to show you this terminal. This terminal and this terminal, they represents methyl group. These terminal represent methyl group, and the carbon and carbon, the junction must have sufficient number of hydrogen atom or heteroatom in order to satisfy the tetravalency of carbon. Children, I hope this point is clear to you. Now, in cyclic compounds like cyclopropane, cyclopentane and chlorocyclohexane, the bond line formula is shown here. So cyclopropane, it's a cyclic compound, it's a cycloalkane, 3 carbon atoms, as it is propane. 3 carbon atoms are attached in the form of a cyclic structure, and in order to satisfy tetravalency of carbon, each carbon atom is attached to 2 more hydrogen atoms. So I am writing here carbon with 2 hydrogen atoms. Similarly, the remaining 2 carbon atoms will be attached to 2 more hydrogen atoms. Then this carbon with 2 hydrogens, this carbon with 2 hydrogens. Now how to write the bond line representation? So bond line representation will be written like this. It is understood that each carbon is attached to 2 hydrogen atoms. So we don't write carbon and hydrogen in the bond line notation. Next one is the cyclopentane. So I am going to write the structure of cyclopentane, but first I'll write this is the structure of cyclopropane. This is the structure of cyclopropane. Now we will write cyclopentane. So cyclopentane will have 5 carbon atoms. So I am writing the structure here. First we will write 5 carbon atoms, and each carbon atom will be attached. Each carbon atom will be attached to 2 hydrogen atoms in order to satisfy tetravalency of carbon. So you can see here. So this is the structure of cyclopentane. Now we can write this structure by means of condensed structure like this. So this is the structure of cyclopentane. Now so I am writing here this is cyclopentane. Now the last cycloalkane was chlorocyclohexane. So first I am writing the name here. Chlorocyclohexane. So we will write 6 carbon atoms in a cyclic form. So we will write 6 carbon atoms in a cyclic form. 1, 2, 3. Then 4, 5, 6 carbon atoms. And each carbon atom is attached to 2 hydrogen atoms. In order to satisfy tetravalency of each carbon. So 2 hydrogens here, 2 hydrogens here. Similarly, the remaining 2 carbon atoms will be attached to 2 hydrogen atoms. So this is but we had chlorocyclohexane. So what we have to do, any of the hydrogen atom, you have to replace by chlorine atom. So I am writing here Cl. So this is the structure of chlorocyclohexane. How you can represent it? You will write this is simple cyclohexane, but as one of the carbon atom is attached to one chlorine, so you have to represent chlorine as it is a heteroatom. I hope this is clear to you. Now children, we are going to solve some of the NCERT questions. First question is that expand each of the following condensed formulas into their complete structural formulas. So this is the condensed formula. In this condensed formula, you have to write in the form of complete structural formula. So you can see here, first you have CH3. So CH3 means carbon atom is attached to 3 hydrogen atoms. So we will write in the form of complete structural formula. You have to show carbon and 3 carbon hydrogen bonds. Then you have second one is CH2, so you will write carbon and 2 of the hydrogen atoms which are attached to it. Third is carbon, but carbon is attached to oxygen. Between carbon and oxygen a double bond is there. You can see now the tetravalency of carbon is also satisfied. Then you have carbon which is again attached to 2 hydrogen atoms. Then you have carbon which is attached to 3 hydrogen atoms. So this is the complete structural formula of the compound which is given in the question. Nomenclature we will study in the next video. So actually this compound is pentane 3-O. Now we will see the next question. Again you have to write the complete structural formula for this compound. So first we will write first carbon atom which is attached to 3 hydrogen atoms. So we have written carbon with 3 hydrogen atoms. Then we have carbon with hydrogen. Then again double bond carbon with hydrogen. Then we have CH2 taken thrice. So you have to write the CH2 unit 3 times. CH2. One more time you have to write. Then one more time you have to write. And finally we have CH3. So I hope it is clear to you. Organic chemistry actually it's very simple. If you understand the tricks, if you understand the method, it is very easy. Now next question. For each of the following compounds, write a condensed formula and also their bond line formula. So you have to do two things here. First you have to write the condensed formula. So first say children we have OH and OH is after that we have CH2 written 3 times. So what we will do? We will write OH. Then we will write CH2 taken thrice. OH. Then we have CH2 taken thrice. Then we have CH. CH is attached to CH3. So CH, CH3. And here you can see that this CH is attached to 2 CH3. So we will write CH, CH3 taken twice. So this is the condensed structure of the compound which is given in the question. Then you have to write the bond line structure. So for writing the bond line structure, children, we can convert the same compound into the bond line structure. Children, you can see here that the terminal group is not CH3 group. Terminal group is a functional group, OH functional group. After that, you have 3 CH2 groups. So we will write 1 CH2, 2 and 3. So you can see that we have 3 CH2 group, 1, 2, 3. Then here this you have a CH3 which we will write by a free line. Then again you have CH. Then this, so you can see here we have OH. And the CH2 taken thrice is represented by 1, 2 and 3 lines. Then you have CH which is attached to CH3 group. Then again you have a CH which is attached to 2 CH3 group. So you will write like this. So student, this is the bond line formula for the compound given in the question. I hope it is clear to you. Then next one is N triple bond C CH OH C triple bond N. So what you will write on this OH, you have CH. OH, you have CH, and this CH is attached to CN taken twice. So this is the condensed structure. Now how to write this condensed structure into a bond line structure? What you will do? First of all, you will write CH in the center, and you can see that each CH is attached to 2 CN. C triple bond N. So what you will do, you will write here C triple bond N. Then what you have? You have CH. And on the CH you have OH. Then again C triple bond N. So I hope it is clear to you. Center I have written CH. On CH you have OH and two cyanide groups, C triple bond. One more compound is here. So you can see this is the structure. If you count, you can see you have 1, 2, 3, 4, 5, 6, 7, 8. This is the structure of octane. You can see 3 carbon atoms. So how we can write the complete structure? First we will write C. You can see I'll write like this. Again we have C. Total we have 8 carbon atoms. Then I'm writing this. So if you count, you can see we have 3, 4, 5, 6, 7, 8 carbon atoms, and each carbon atom is attached to required number of hydrogen atoms to satisfy its tetravalency. This carbon atom with 2 hydrogens, this carbon with 2 hydrogens, this carbon with 2 hydrogen. So now you can see this is the complete structure for octane. Again 2 hydrogen atoms. And this last one is having 3 hydrogen atoms. So you can count here. I'll use this is 1, 2, 3, 4, 5, 6, 7, 8. I hope it is clear to you. Now the next compound you can see. So here a triple bond is there. So first of all I am writing C. And between carbon and carbon you have a triple bond. So you can see here carbon and carbon triple bond. So in order to satisfy a tetravalency, one hydrogen will come here. And this carbon in turn is attached to a carbon atom. And this carbon atom will be attached to 2 hydrogen atoms. And this is again attached to a carbon atom, which is having a hydrogen and a OH group. Then again you have C, and this carbon atom is attached to 3 hydrogen atoms. So children, I hope it is clear to you. Now the next compound. Again, it will be quite simple for you. So first I am writing carbon and carbon single bond. Now you can see that each carbon, these are the 2 carbons. I'll show you with this color pen. I have written these 2 carbons here. So the carbon and each carbon atom is attached to methyl group. Methyl group means CH3. Similarly, this carbon is attached to methyl group means 3 carbon with 3 hydrogen. So now if you look at this carbon atom, you can see its valency is 3 only. So you have to attach it to one more hydrogen atom. Similarly, on this side you have carbon. Each carbon is attached to 3 hydrogen atoms. In the form of methyl group you have. This is also one more methyl group you have. And here you have a hydrogen atom. So children, I hope it is clear to you. You can see that. So children, I hope that it is clear to you. Now we will see what are the topics we have covered today. We have studied about the structural representation of organic compounds. Then we have practiced for writing complete condensed and bond line structural formula. Then we have written bond line structures of some cyclic compounds also. And in the end, we have discussed some of the NCERT problems. So children, thank you so much for watching this video. I hope you have understood each and every point and you have enjoyed this video. And don't forget to subscribe my channel in case if you have not subscribed. And please like this video and share it with your friends. Thank you so much. Have a nice day.